Welcome to This Explainer. You know that feeling when you're staring at a frozen screen, frantically clicking your mouse, or you get that dreaded low memory warning right in the middle of something super important? Yeah, we all know the universal frustration of device slowdowns. Well, today, we're going to demystify the invisible engines running inside your computer and your phone, helping you understand exactly what is happening under the hood.
Okay, let's quickly run through our roadmap for today. We've got 1. The memory mix-up, 2. ROM, the spark of life, 3. RAM, the digital workspace, 4. Volatile versus non-volatile memory, and 5. Why we need both.
Starting right off with Section 1, the memory mix-up.
You know, when a device starts lagging, you've probably heard people say, oh, you need to free up memory, tossing the words memory and storage around like they're exactly the same thing. But functionally, they are entirely different beasts, which leads us to the core question we're answering today. Why do computers actually need two completely different types of memory to function? Why not just have one massive memory bank?
Take this quote from a user over at CNET. They asked, I know the problem has to do with RAM, but what types of files can I delete to free this up? It perfectly captures the confusion out there. The absolute truth is deleting your old photos or documents will for sure clear up your storage drive, but it's not going to do a single thing for your RAM. To understand why, we really need to look at how a computer wakes up in the first place.
And that brings us to Section 2, ROM, the spark of life.
Let's trace the journey of your device from the exact microsecond you hit that power button. Meet ROM, or read-only memory. This is non-volatile memory used to store permanent data. Before your computer can even load its operating system, it has to know how to turn on, right? ROM stores those absolutely essential, low-level startup instructions, things like the BIOS or UEFI. Without ROM, your computer is basically in a coma. It wouldn't even know how to wake up or recognize its own hardware.
Now, what's genuinely fascinating here is how ROM has evolved over time. Historically, read-only literally meant hardwired and totally unchangeable. But think about this progression. We started with PROM, which was programmed just once. Then came EEPROM, and get this, you literally had to expose the chip to ultraviolet light to erase it. Crazy, right? After that, we got EEPROM, which allowed electrical erasing, and finally, we arrived at today's standard, Flash ROM. It can be erased and rewritten in blocks, which is exactly how modern firmware updates are even possible.
But despite being so crucial, the system ROM in a typical PC is actually incredibly tiny. We're talking just a few megabytes of data. And that's simply because it only needs to hold those foundational startup instructions. It does its critical job, wakes the system up, and then immediately passes the baton.
And it passes that baton right here. Section 3, RAM, the digital workspace.
Now that your system is awake, it's ready to work. And work requires a totally different kind of memory. Enter RAM, random access memory. Now, unlike ROM, RAM is volatile. That means it's a super high-speed temporary holding ground that completely wipes itself clean the absolute second your device loses power. Whenever you open a web browser, load up a heavy video game, or edit a document, it gets loaded straight into your RAM so your processor can grab it at lightning speed.
If that still feels a bit abstract, I absolutely love the classic desk analogy for visualizing what's going on under the hood. Think of your RAM as the actual surface of your desk. It's where you spread out your current active projects so you can grab them quickly. But if that desk gets too cluttered, your workflow slows down. Now, your hard drive, that's the filing cabinet sitting over in the corner. It's way bigger and permanent, but it takes you a lot longer to walk over and fetch things from it. And your ROM? That would be the instruction manual glued directly to the desk itself, telling you how to open the drawers and use the workspace in the first place. Because RAM is your active workspace, you obviously need a lot of it. Contrast those tiny megabytes of PC ROM with RAM, which we measure in massive gigabytes, typically anywhere from 8 to 64 gigs in modern machines. You literally need this huge space to juggle dozens of browser tabs, high-end gaming, and large files all at the exact same time without your system completely choking.
To make all that seamless multitasking happen, your system actually relies on two main categories of RAM. First, you've got SRAM, or static RAM. This stuff is super fast, but really expensive, so it's mainly used for the tiny cache memory directly on your CPU. Then you have DRAM, or dynamic RAM. This is your main system memory. Your modern computers are using highly evolved generations of DRAM, like the DDR5 standard, which gives you incredible speed and energy efficiency for your everyday multitasking.
Section 4, Volatile versus non-volatile memory.
The crucial point here is really understanding the stark defining contrast in how these two technologies retain information. Volatile memory, like your RAM, demands a constant, uninterrupted power supply. The very second you pull the plug, it develops total amnesia and forgets everything. Non-volatile memory, like your ROM, safely locks that data away long-term. Power or no power, it remembers exactly what it was told.
When you put them head to head, it really illustrates the ultimate showdown under the hood. They balance each other out flawlessly. RAM is volatile, designed for constant read and write access, is incredibly fast, but it is way more expensive per gigabyte. ROM, on the other hand, is non-volatile, primarily read-only, a lot slower than RAM, but it's much more cost-effective for permanent structural storage.
Which brings us to our final stop today, Section 5, Why We Need Both. So why hasn't the tech industry just picked the best one and stuck with it? Well, because it's the perfect partnership. These two different technologies cover each other's weaknesses flawlessly. ROM is your reliable anchor. It guarantees your device can always start up, and it secures critical cryptographic keys. RAM is your high-speed athlete, giving you smooth multitasking and snappy app performance. Without ROM, your device is just a useless brick that can't even turn on. And without RAM, your device would be agonizingly, unworkably slow. But, there is a really fascinating caveat to all of this when we look at the mobile world. Smartphones actually blur these lines quite a bit. In mobile phones, the definition of ROM expands. They use massive flash ROM chips, we're talking anywhere from 64 to over 512 gigabytes, and they use it to store not just the core operating system and firmware, but also to act as your permanent mass storage for all your downloaded apps, your personal photos, and those huge 4K videos.
And as technology rapidly advances, you really have to wonder what's next. We're already seeing the development of technologies like NVRAM, non-volatile RAM, which literally tries to combine the blazing speed of RAM with the permanent memory of ROM. So, will these innovations eventually erase the dividing line between RAM and ROM forever? It's a thrilling prospect for the future of computing. Thanks for joining me for this explainer, and keep questioning how your tech actually works.